Hi everyone, and welcome to this grade 9 mathematics lesson where we're going to be calculating the gradient of a line using the formula. My name is Miss Donnell Phillips. Let's get started. In our previous lesson, we would have been calculating the gradient of lines by just counting the number of places moved on the x and the y axis. But in this lesson, we're going to use the formula to actually calculate the gradient of lines. So if we have 2 points, point P, x1, y1, and point Q, x2, y2, and these are 2 points on a line, then the gradient of that line could be calculated by using y2 minus y1 divided by x2 minus x1. So sometimes we may be given the graph of a specific line to find its gradient, and sometimes we may just be given the points or 2 points on that line to find its gradient. It is so much easier for us to just look at the graph and probably count the change in x and the change in y and do the division. But sometimes because we don't have that visual, we will just need to use the formula in cases like that to calculate the gradient. So, using the formula, we have a line that you could see. We're going to extract 2 points, and the 2 points that are identified are 3, 4, and 5, 1. We're going to substitute the values. We're going to call the first point A, 3, 4, and the second point B, 5, 1. Now, substituting these values into the formula, y2 subtract y1 divided by x2 subtract x1, we have m is equal to 4 take away 1 divided by 3 take away 5. 4 take away 1 is 3 and 3 take away 5 is negative 2. So the gradient of this line is negative 3 over 2. A negative gradient denotes that the line is sloping downwards, and we can see that right there. Next example, we have a line. We extract the 2 points. First point A, we have 4, 3, and the second point B, negative 2, negative 1. Substituting these values into the formula, y2 subtract y1 divided by x2 subtract x1, we have m is equal to 3 subtract negative 1 divided by 4 subtract negative 2. And we know from adding and subtracting directed numbers that when we have a subtraction and a negative sign coming together, it becomes a positive. So instead of saying 3 subtract negative 1, we now have to say 3 plus 1. And instead of saying 4 subtract negative 2, we can say 4 plus 2. 3 plus 1 gives us 4, and 4 plus 2 gives us 6. So the gradient is 4 over 6. Breaking it down or reducing it, we have that the gradient is equal to 2 over 3. Positive gradient denotes an upward slope. So now we're going to work an example without actually having the graph. It says, if 2 points on a line are A, 5, 4, and B, 8, 10, what is the gradient of the line? Remember the formula, m is equal to y2 subtract y1 over x2 subtract x1. Now before I move on, you probably may be a little confused as to where we got the y and the x from. We know that in any ordered pair, the first value is the x value and the second value is the y value. So A, 5, 4, the x1 would be 5 and the y1 would be 4. And in B, 8, 10, the x2 would be 8 and the y2 would be 10. So now that we have those, we could substitute them into the formula. So the gradient is equal to y2 10 subtract y1 4 over x2 8 subtract x1 5. So we have 10 subtract 4 divided by 8 subtract 5. 10 take 4 gives us 6 and 8 take 5 gives us 3. 6 divided by 3 is 2. So the gradient of that line that has the 2 points A 5 4 and B 8 10 is 2. Now what can we conclude about the graph of this line based on its gradient? Would the graph be slanting upwards? Would it be slanting downward? Would it be a horizontal line? Would it be a vertical line? If you said that the line slopes upward, then you are correct. Because the gradient is a positive gradient, then the line would be sloping upward. Next example. Given the points L, -4, -3, and M, -8, 6, find the slope of the line. Formula again. Gradient is equal to y2 subtract y1 divided by x2 subtract x1. Let us identify x1, y1, x2, and y2. So x1 is going to be -4, y1 -2, x2 -8, and y2 6. So we're going to take these values and plug them into the formula. So the gradient is equal to 6 subtract -2 divided by -8 subtract -4. Gradient is equal to 6 plus 2 and it is divided by -8 plus 4. When we work this out, 6 plus 2 gives us 8 and the -8 plus 4 gives us -4. So 8 divided by -4 is -2. So the gradient of this line that has 2 points, L -4, 3 and M -8, 6 is equal to -2. Question. What can we conclude about the graph of this line based on its gradient? Is it sloping upwards? Is it sloping downwards? Is it a horizontal line or is it a vertical line? The line is sloping downward. Remember, negative gradient means that the line is sloping downwards. So again, I'm going to refresh your memory. A negative gradient means that the line slopes downwards. A positive gradient means that the line slopes upwards. A gradient of 0 means that the line is horizontal. And an undefined gradient means that the line is vertical. And again, the higher the gradient of a graph at a point, the steeper the line is at that point. So for your homework, you're going to use the formula to calculate the gradient of the following lines. Number 1, the first point, A, 0, 0, and B, 5, 2. Number 2, P, 1, 3, and Q, -3, 4. The third one, L, 5, 2, M, 6, 5, and lastly, X, 8, 8, and Y, 8, -8. After you would have calculated the gradient of these lines, you can state whether the graph would be sloping upwards, downwards, or if it's a vertical line or a horizontal line. To summarize today's lesson, we can calculate the gradient of a line without actually seeing the graph. All we need is 2 points on that line, and we can use the formula m is equal to y2 subtract y1 divided by x2 subtract x1. After we would have calculated the gradient of the line, if the gradient is positive, we know for sure that that line is sloping upwards. If the gradient is negative, the line is sloping downwards. If the line has a gradient of 0, it is a horizontal line. And if the line has an undefined gradient, it is a vertical line. This has brought us to the end of this grade 9 mathematics lesson, where we would have explored calculating the gradient of a line using formula. My name is Ms. Donnell Phillips. See you next time.